Hello, my name's Andrew Koch and I'm an engineering psychologist with Naval Air Warfare Center Aircraft Division. We're here today in the Innovation Hub, the iHub, to talk a little bit about robotics and some of the robotics work that is done at Pax River. This place is focused on developing new and exciting products, exploring interesting ideas, and just really trying things out. Specifically here on this table, we have some of the robots that we've been working with recently. We have everything from a very simple robot to a line follower to a robotic arm that will do some really complicated and interesting tasks. We've got a couple of people here who are really excited to talk about some of the robots that they developed and some of the work that they've done. First up is Zoe.
Thanks, Andrew. Hi, I'm Zoe. I'm a computer scientist here at Naval. I'm going to talk to you about the software that we use to plan out our robot designs before we make them in real life. We have an example here of a simple robot that uses 2 motors, a microcontroller, and a battery. The 2 motors are the yellow portions of the image. The microcontroller, or the brain of the system, is the blue computer, and the battery is the 9-volt down at the bottom. The microcontroller works as the brain of the system to tell the motors what to do, using the code that is on the side. We can then take what we have made in this software and put it into real life on a robot, such as the simple robot. We have our 2 motors, our motor controller, our microcontroller, or the brain of the system, and our 9-volt battery. We know that it will work because we tested it in the software first. So all we have to do is turn it on and run it. The software can also be used to set up more complex systems, such as this robot right here. This robot has more motors and it has sensors involved. The software can plan out the same kind of system that we created for the simple robot, but for this robot instead. Andrew will talk to us more about how this robot works.
Thanks, Zoe. That was really interesting. So what I've got here is a little bit more of an advanced robot than Zoe just showed you. This is a robot that we put together from a kit that we found online. You'll notice that it's very similar to the previous robot, but it has a couple of extra features. You'll notice that it has 4 wheels instead of 2. Motor for each wheel. It has a motor controller inside, a breakout board, and a microcontroller. But what's really different is that these are sensors that are attached to the robot. This is an ultrasonic sensor that can be used for collision avoidance and for avoiding obstacles. We're not so much going to use it in this test, but it's something that's really valuable and we can use for other applications. The important thing here is what we got on the bottom is called a line following module. So this is a sensor that has 3 segments. Three little lights and sensors that helps the robot to identify the tape that we have here on this table. So as the robot goes over the tape, each sensor will be able to identify where the tape is, and the robot will use that data to try and stay on the line. So let's take a look at it in action. So pretty cool. One of the things that you might have noticed as the robot is turning, sometimes it jitters a little bit. And that's because the line following module has different sensitivities. As you adjust the sensitivities, it gets a little bit better at identifying where the turn is and making it a smoother process. And there's some more advanced techniques, if you're really interested in coding, of making that process even smoother and even more graceful. It's very important that you have a sensor that meets the task, because everything that the microcontroller is doing is dependent on the data it's getting from the sensors. So the more data you have, the more accurate, the faster that data is, the better that robot can do its task. So why is this important? Well, this is a really cool learning tool. It's a really cool toy, but why does it matter to the Navy? Well, so the Navy does have a lot of robots that helps the sailors and employees and people in the field do its job. There's many different applications. One of the things that you might have seen out on TV is something called an explosive ordnance disposal robot, and the Navy has those too. It's a robot that's used for disposing of dangerous devices, things like bombs or mines. It uses the sensors to identify that object and to neutralize it. That's one of the many applications that we use. This facility is dedicated to innovation and finding out new ways that we can use robotics to help everybody at PAX do their job better and to help make things a little bit more efficient. So my colleague Nick is going to be talking about a little bit more advanced robot, this robotic arm here. So take it away, Nick.
Hello, I'm Nick Merkrakis. I'm a physicist at the Naval Air Warfare Center Aircraft Division in Patuxent River, Maryland. And today I'll be showing you one of our more advanced robotics projects, the robotic arm. This robotic arm is sometimes referred to as a Stanford arm because it's similar in design to one of the earliest robotic arms ever built by Stanford University's Artificial Intelligence Lab way back in 1969. This particular robotic arm is an open source model whose schematics are readily available online. So if you'd like to build your own, you can download all of the files and code needed to do so and simply order the parts. It utilizes 3D printed plastic components for the structure and stepper motors for controlling the motion, the various degrees of freedom. So a stepper motor is just a high precision motor for turning in small increments of 0.9 or 1.8 degrees. You frequently see them in devices like 3D printers that need that high level of precision with positioning to put the extruder where it needs to go to build three-dimensional objects. It also has belts for turning the gears to allow for rotation and various motion. So we've got a microcontroller similar to what you've seen in the other robotics projects for giving the commands to each of these stepper motors, and a large power supply to go along with it because stepper motors tend to draw a lot of current. So we got a simple demonstration for you here that just kind of shows the range of motion that the robotic arm is capable of. In order to control this robotic arm, we've developed our own graphical user interface, a GUI, in MATLAB. And what that is just a software program that's got buttons and sliders and any other components you want for controlling various aspects of whatever you're trying to do. So you just lay out the GUI how you want it to be, and then you add in lines of code to give it functionality so that you can say move the stepper motors, or if you have sensors, it can read data from sensors, all using that very simple microcontroller. Now I'll give you a brief demonstration of the ways in which the arm can move. So you got the base turning, and the shoulder, and then the elbow, and then the wrist will turn. This has been kind of a basic overview of the kind of functionality you can get with one of these Stanford arms. If you'd like to build your own, the schematics are readily available online. This is a work in progress for us, and in the future we're looking to implement more complex behaviors such as screwing in a light bulb or moving objects around. Now I'll turn it back over to Andrew, who's going to wrap up our discussion of the robotics projects.
Thanks, Nick, and thanks, Zoe. So this has been really a great opportunity to talk about some of the stuff that we've been doing here, as well as go over some of the robots. You had the opportunity to see this really simple robot. Zoe talked about how she designed it and how she used tools to build it from the electronic model to a fully physical and fully functional model. We have this line following robot that we developed, and this is a great example of how to use sensors and how to use code to accomplish an autonomous task. And then Nick talked a little bit about this robotic arm that we've been building and how that can work on code that we developed on the computer, and it can be used to accomplish very precise and very accurate tasks. This has been a great opportunity to discuss the basics of robotics. And one thing I'd like to point out is that each of these robots uses a microcontroller like this. It's a very affordable, it's a very easy way of getting started with programming. You can find these microcontrollers at a local physical retail store, or you can find it online. And this is a very approachable way for people of any age to get started building something and seeing it work. So I highly encourage you to take a look at the many resources that are out there and to start building something and seeing it come to life. It can be a really great way to get started with engineering. This has been Andrew at the iHub, and I highly encourage you to keep an eye out at the next STEM Festival for the Fab Lab and some of our robotics equipment. Who knows, you might even see us there.